If you follow my channel, then you will no doubt recognise this. It is of course the Wren computer that I've been working on. In fact, over the last 18 months I've been looking at a number of these. I've posted quite a few videos. I repaired a few of these quite a few years ago, and fairly minor faults. They didn't belong to me. I repaired them for someone else, and didn't see any more of these until sometime last year. And I was asked to have a look at one, repair it and restore it, so I agreed to do that. And I'd never really used one to any great extent, and as part of the repair process I got to know the machine fairly well. And one of the things that has occurred to me, or that I can't really understand with the Wren, and this has become more apparent the more time I've spent working on them, is why they weren't more popular back when they were being manufactured. A lot of machines popped up around the same time, and I've worked on many different types from that era. And as I say, the more I've worked on the Wren, the more surprised I've become by the small number that seem to be around. And it's what I'm really getting at is that the machine's very complete. It's unlike many machines that popped up back then that were kind of half-hearted attempts at jumping onto the personal computer bandwagon, the hobbyist or even the professional or semi-professional bandwagon computer type systems. The Wren is a complete package. By that what I mean is the system, the hardware itself, has all the features you would expect in quite a comprehensive top-end machine. It's got DMA built into it, floppy drive control, Winchester drive, various ports, a built-in modem, and the list goes on. It's got many features that you'd only normally find in much bigger, more expensive machines. This wasn't particularly cheap back then, but it was by no means particularly expensive either. It was, for what you got, it was quite a very cost-effective system. And giving it a lot of thought, the only thing I can really come up with as to why not that many were sold was it was undersold. And looking at the information that seems to be around for this, and bear in mind at the time it wasn't like today when people in general, if they're out to buy a machine like this, would fully understand what they're looking at. I think back then the potential market may not have fully appreciated what this machine could offer them, and hopefully I'll be able to clarify the point I'm trying to make in some future videos when I'll be making accessories for this and writing software for it. But what I wanted to do in this video was just a quick catch-up for anyone that has been following this series on these repairs. And if you were getting involved with these repairs, then you'll know that I put out a request for anyone to help me reverse engineer the firmware. So this is the disassembly listing that I've shown in previous videos. Also, I wanted to reverse engineer the hardware and try and get some schematics put together. As I say, it's quite an advanced system, so the way the circuits are laid out is a bit weird if you don't have the schematics, and it became apparent that this was going to be quite a difficult system to work on without the schematics. So I went to the trouble of actually purchasing the first of the machines that I was showing on these videos. It didn't belong to me. I was repairing it for somebody else, but I came to an agreement with the owner and I bought it, and the intention was to reverse engineer the hardware, the PCB, and to try and get some working schematics so that they could be used to properly support these machines in future. And the reason I wanted to go to all this time and trouble is because, as I say, the machine is a very interesting machine, and if you are into this type of computer system, then this is one that you would find extremely interesting, and certainly it's one that I decided I wanted to have one. But as I got to the point when I was preparing to send out the disassembly listings to the people that offer to help. So thanks to those people that offered to help with that. We managed to get hold of one of the original developers of the system. And when I say we, I repair equipment on occasion for a museum, and they are very supportive for what I'm doing. I try and support them, and it's a very kind of symbiotic relationship where we seem to have the same goals, but we tend to work together fairly well, and as I say, the relationship seems to work very well. They're very good at tracking down things such as information, and they managed to get hold of one of the original developers. He was extremely supportive and very helpful as well, and I believe the museum are still talking to him. I can't give you a great deal of information about what's been discussed, other than to say that he was generous enough to allow us access to some of the original technical documentation. Now, one of the issues, of course, is that back when this machine was being designed, there weren't the same infrastructure, CAD systems, software to do this sort of development. If you've come into this sort of thing over the last 10 or 15 years and you've started using PCB design programs, using modern PCB manufacturers, Googling for spec sheets, this sort of thing, then it will be fairly difficult for you to appreciate just how hard it was to develop something like this back in the 80s. The internet did not exist. If you wanted a spec sheet, for example, for something like the floppy drive controller chip, you may well have to buy it. The first time I used the 68,000 processor, I had to buy the spec sheet, and it cost me, I think, the equivalent of about £60 in today's money. And it was a hard copy. You couldn't download it, of course. And you had to do that for all the devices that you wanted. You could get data books for the TTL stuff, of course, but you couldn't just go on to the internet and Google how do you use a floppy drive controller. You had to go through the spec sheet and figure all that out. Also, there weren't big libraries of sample code and this sort of thing. This was very much at the pointy end of development. But also, when it came to drawing schematics and designing boards, it was much more difficult back then. You couldn't just use a CAD system to make a board the way that we do today and modify it if you wanted to. And I designed systems back then, and it was a very tedious, very labour-intensive process. And so the schematics tended not to be available in the form that you'd expect them to be today. So there weren't PDFs of them, there weren't images and CAD files available. And quite often they only existed in terms of hard copies. And that's what we managed to get hold of from the original developer, is some of the original hand-drawn hard copies of the schematics. Now, the problem, of course, they're just drawn on paper. They are 4 decades old, and so they are not in particularly A1 condition. If I give you an example of what they look like, unfortunately I'm not at liberty to pass out this information, but hopefully they won't mind me showing just some small samples of it. So this is kind of this is an image of what we're up against, and I didn't take this. This was one of the guys at the museum. He spent a huge amount of time on this. The original schematics are on 6 A1 sheets, and they've been folded up for 40 years, and they're very badly faded. This is actually the result of some enhancement. This is they're not quite as good as this to look at. But the issue we have, of course, is some of them are quite difficult to read. And so what he did to try and capture these was to take zoomed up photos of all the areas of each of the schematics, painstakingly stitch all the images together, enhance them, try to improve the readability, the contrast, but even after all that, the resulting schematics are still quite difficult to read. And as you know, if you've done any fault finding, the last thing you want is to have to try and figure out what each schematic is trying to tell you. So what I decided to do from this point, they're extremely useful and did tell me a huge amount, and it was quite gratifying how close I got to the design, and that was confirmed by the schematics as far as I could read them. So these are incredibly useful, and luckily they do seem to match very closely to the particular board that I have. So what I decided to do was to go from the enhanced copies that the museum had put together and try and turn those into much more readable schematics. Now, as I said, I can't show you the entire schematics. I'm not limited to pass this out. But I'm redrawing this in my CAD system. What it means is that I end up with a working set of schematics. Very painstaking process. I think you've seen me go through this type of thing before, and it takes a very long time, because what I have to do is go through the original schematic, and I can only read about a third of the pin numbers. So what I have to do is, for each connection on the schematic, I have to buzz it out with a meter and find out which IC and which pin is connected to which other pin, and then put that into the CAD system. The only other issue, of course, is, as with any hand-drawn schematic, there are the occasional error, and or there is an occasional error, and it means that I have to take that into account when I'm trying to figure out exactly how it's interconnected. So I'm correcting those as I go, and hopefully in a few weeks I should have a set of schematics that I can use to properly support these machines. The other thing that came up was, as you know, I've been looking at reverse engineering the firmware, a very long, slow and tedious process, and as I said, we were going to put this out, and several people had offered to help with this. Again, I can't show you too much, but part of the information that we managed to get hold of is the original source code for the ROM chips, the BIOS. And again, very gratifying as to quite how close we'd managed to get so far with the disassembly and the reverse engineering of this. And we were on the right track. It just would have taken months and months to go through the whole thing. But having access to the original source code makes this so much easier, and it gives a very good insight as to how this machine works. And when that comes to supporting and fault finding, it's at least an order of magnitude easier to work on these. You can go through the source code and see exactly what a particular part of the machine is supposed to be doing. You can relate that to the schematics, and of course the whole thing starts to make sense, and it's far easier than trying to do the whole process in reverse. So huge thanks to the original developer. Again, I can't give you his name at this point. I'm hoping I can give out more information in the future, and thanks also to the museum for supporting me in this. That's made life a huge amount easier, and as I say, it's quite a nice way to work. They obviously have the same type of goal that I do. So anyone interested in this, you got any comments? As I say, I can't send out the information just yet, but if the developer is watching, thanks very much. And if you are happy for me to send out this information, then please let us know. If you want us to restrict the information, then again, let us know what you want restricting. We do go through all this, by the way, and make sure there's nothing of a personal nature in the documents that are supplied. It's also quite interesting to look through this old information as well. It's if you're interested in this sort of system like I am, then the information is incredibly interesting to look through. So that's it for this video. Just a quick update in case you were wondering why I hadn't posted the information on the website. As I said I was going to. It looks like it won't be needed. We can save ourselves a lot of work and time and effort. It will take quite a lot of effort to get the schematics into a fully readable form, but having the originals, of course, makes it a massive amount easier. Okay, so it's looking quite promising that we'll be able to support these machines going into the future. If you do have one that you'd like repairing, I should be able to help in one way or another, but the general goal is to try and get as many of these machines up and running as we possibly can. And in future videos I'll be showing how to write software for them and adding various accessories and experiments with them.